So this is the fourth webinar that we are organizing in collaboration with NSBM and the other universities. And we have got an overwhelming response for all four webinars, including this one that we are doing, right? So the fourth session today, again, we brought a very interesting topic, right? So it's all about, getting yourself up to speed with the industry and to see what's happening new out there, and bringing in these resource people or subject matter experts who could share, the ones who really do the job, to come and speak to you what's happening out there. So let me introduce today's speaker or the facilitator or the SME is Misnad. Maybe you must have seen him quite often if you're following this subject on LinkedIn or on Medium or any other platforms, because he's a very keen, passionate blogger who always speaks about this subject and is extremely passionate about this. And he's one of the greatest assets we have as well. So without further ado, how we are going to do this is, since this is a new subject, probably a subject particularly even for me, I have not heard much about this latest trends. We thought it's a good idea for us to ask Misnad to take us through few slides and get us, all the participants here, up to speed, and then we can have a productive conversation and a discussion. Over to you, Misnad.
Thank you, Sampath. So I just noticed you mentioned saying that the age doesn't show. Good thing I'm on Zoom, so you're missing out the. All right. Okay. And by the way, in no means does that mean what you call it's a side effect of what we are doing, right? So TechOps is a very interesting subject. Okay. It's basically if you look at the entire software life cycle, it's the other end of the spectrum of it, right? You build something and then you have to nurse and look after it, right? So I'm just going to start into some of the slide where we'll be sharing my screen. If Sampath, just let me know if you can see it as well.
Yes, Misnad, we could see.
Can say it? Great. Okay. Good. Yeah. So, team, just thank you all for joining, right? And thanks, Sampath, for this opportunity. So, in a nutshell, like Sampath did mention, there are many buzzwords, right, in the industry around operations, okay, software operations. And like I mentioned, operations and TechOps is what happens at the other end of the software development lifecycle, right? So you hear words like TechOps, Devops, NoOps, AIOps, and SRE, and it's really mind-boggling to try to figure out what these are. One of the main reasons is a lot of these are used interchangeably, okay? So let's go into detail. But first, before getting into any of these buzzwords, I just want to explain to you what TechOps means, right? What the essence of TechOps is. So let's just look at the standard grind, right? Just trying to hide this little top element. Okay, I won't be able to do that. So let's just look at the usual grind, right? What actually happens during, say, a standard agile life cycle. So a lot of focus is given in terms of developing the software, right? So you develop it, you build it and test, right? And it's great. You keep doing that. So you look at your low code, no code initiatives, you try to build open source, you try to build COTS products, whatever it is, right? And then you nicely package it. You focus a lot, especially when I hear this in DevOps, right? DevOps is all about CI/CD. And if you ask some people about what DevOps is, some actually will say DevOps is CI/CD, right? What is CI/CD? Continuous integration, continuous deployment or delivery, right? However, you're deploying something into production, okay? You're just sending something into production. And when you look at, say, Agile, you're continuously developing it in multiple sprints, right? So you develop in little bits and pieces, develop and deploy into production. So with each development or delivery that you make, you're actually complicating the production environment, right? So you focus on good software engineering disciplines. You look at automating your build process, your deployment process, your testing process. We look at automated testing, test engineering, and all that stuff. But what happens when it goes into production, right? Understand you can actually build something. However, unless you cover the other element of things, because it has to be used by people, unless you cover that element of things, you're not done yet, right? It's a job half done. So let's take a look as and when this what you call the production environment keeps on getting more and more complex, what really can happen. Okay. Sampath, just to understand, I just want to get a feel. Are you all able to see the top section of my screen? Because
yes, it starts from when things go wrong, right? That's the top section. Yes, right. I can see that. I'm sure the participants also. Yeah.
Great. There's some overlay on the Zoom thing. That's good. All right. So just look at what happens with the production system, right? So production system, usually when you deploy something, unless you're being prehistoric, you don't deploy it onto a single server, right? And nowadays you deploy things to the cloud. And by cloud, it doesn't mean up there, right? It means it's there in some physical data center somewhere, right? Or multiple data centers spread across the globe. Now, cloud is something that's just taken for granted, okay? Because you assume that, okay, just because you deploy something to cloud, it's always available, right? But what happens when, say, Amazon has certain failures? They have regional failures, okay? True, they have availability groups and so on, and then they just available zones, they move across zones and so on. What if an entire region fails, right? And if your services are hosted over there, you will have some outage, right? A typical example was in the past, we had Netflix, right? And Netflix had a major outage as well, purely because some of AWS's services failed, right? And then recently there was another one on the content delivery network right across the globe, right? So a lot of websites and so on keep using CDNs for caching. What happens when the caching service provider fails, right? All these images don't load, nothing loads, and it's slow and so on, okay? So things can actually go wrong. One of the worst things that can happen is if the data center does catch fire, all right, or if there's a heat wave or something like that, servers can crash, right? Understand, these are very resilient servers. However, things can go wrong, right? You switch off a fan in the data center and things will fail, right? Air conditioning is affected, the servers will fail, right? They will just shut off automatically, right? Because to save themselves. And trust me, in my experience, I've seen all of these, right? I've experienced all of these areas. The other one is, let's look at security, right? Denial of service attacks, someone can hack into the systems, etc. You can build your systems as secure as possible. However, understand that there's always an evolving threat. What if at some point, maybe a ship goes by, close by, and what you call drops an anchor, okay? And we've seen this, I think, 2 or 3 times in the past as well in Sri Lanka, right? Where the undersea cables which connect the island to the rest of the world get affected. You have these CMEV lines, CMEV3, CMEV4, SMW4, and so on. When those are affected, your entire connectivity goes off, right? The servers may be all fine, but your connectivity is gone off. You have redundant systems, however, they have to resort to slower lines, right? Like satellite connections and so on. So as a user, you're going to be affected through latency, okay? Something called latency. We'll go into detail about that later. The other more recent one, actually, we are facing here as well, is accidental data loss, right? So assuming data gets lost suddenly, you can have a concept of backup or disaster recovery or whatever it is. You lose data, right? What happens to it? You then have to take some time to go and recover. Specialists have to come and recover, but you may never recover all of the data, okay? And until that time, you're affecting your services, your business, right? Take an example, if you are what you call using some service here, right? Let's take, say, maybe an internet service provider as an example, right? Or even, let's take Google, for example, right? Google is something that everyone uses. I know Google is heavily resilient. However, in case you do not have that particular Google page for just 1 minute, okay? What happens? I know a lot of people actually test their internet connections by loading Google, correct? And that's something Google have acknowledged themselves as well. There's no search that happens. They just launch Google. What if it's down? Your first assumption is that, oh, something's wrong with your internet, right? But what if it's actually Google? You can't search, you can't basically do anything, and it affects multiple other things. Now, assuming certain Google services are down, if their sign-on is disabled or logged off or down, you would also not be able to use a Gmail and other stuff as well, right? So what happens to you as a user? You get very frustrated, okay? If that's especially a local company, it's even worse, right? It gets amplified. And we're so used to having resilient service that we can't sustain maybe what you call a few minutes of failure, okay? However, this is something that what you call really emphasizes why the operations element is so much more important in exactly the same way development is as well, development of new features is, right? The final thing is, the more development you do, you can also introduce bugs, okay? If you look at all of this, the ideal system that does not fail, right, is basically a system that does not change at all, okay? You don't introduce any changes at all, and it should be resilient to its environment. Basically, it's unaffected by its environment in a state of vacuum, okay? Can you do this in reality? It's impossible, right? So we've seen people talk about 100% service availability and so on. It's a dream, okay? That's never going to happen, right? For example, the new Matrix movie coming out as well, the Matrix also did have its outages, right? And that's what caused the little problems to come in. So there is no state of nirvana, right, that we have can achieve. But what can we do to minimize the outage? Okay, that's what we'll get into. So when you talk about TechOps, okay, now we'll go into the details of what each of these are, right? There are multiple ways of doing this. Like I mentioned, there are so many different names here, okay? So what does happen when something goes wrong? You can actually refer to different ways of working here. The traditional approach was called sysadmin. Now, sysadmin, why it's called sysadmin is actually systems administrator. And it spawned from the old ways of working where you had Linux admins and so on, right? Who would be experts at operating systems, the network and infrastructure and physical infrastructure, okay? And to be honest, the same approach works with software as well, okay? So it's literally lift and shift into software development as well. Where the sysadmin does not look at code, all they do is looking at the runtime operations of the system, okay? While the developer keeps on pushing in code, right? But what can go wrong in this situation, right? And by no means am I saying sysadmin is bad, right? It is good, however, it does have its flaws, right? Just like everything else has its flaws as well. What happens is you build a divide between the developers and the administrators, okay, and the sysadmins. So when this happens, the developers can push something into production the sysadmin has no clue about, right, or does not properly understand, and they don't know how to monitor this, or they don't know how to react in case of a failure, okay? Or it can be that the sysadmin is so adamant that they don't want to change much in production that they force controls and security controls on the developers to reduce the rate at which development goes through, okay? In either case, it's not a good scenario. It's a negative scenario, okay? But understand the principle of sysadmin. It stems from the Linux systems administrator concept, okay? Then you get into something called CloudOps. Now, this is an evolved version of it. However, it actually takes off from Devops. Now, in the current world, you get many systems moving into cloud, okay? They have cloud services and so on. You build your applications on the cloud. Now, the operations engineers who work on cloud systems, right, dealing with services and managing expenditure on the cloud, and so on, migration from legacy stacks into cloud, they are actually referred to as CloudOps, okay? One difference between this and the sysadmin is that CloudOps advocates the use of code, okay? And I don't mean application code. However, I mean infrastructure as code, right? There's this concept called IAC, or infra as code. In the legacy state, you'd have sysadministrators. They would actually, instead of having code, your infrastructure written as code, you'd need to procure physical infrastructure and so on. However, now with cloud, while you can go into maybe AWS, you get the console and so on, right? That you can, buy new instances and add it to a service, etc. You actually have the ability to write code saying that you want to configure a template like this. You want to have maybe this amount of disk storage space. You want to have maybe this amount of memory, this amount of CPU processing cycles, vCPUs, etc. Right? And you can actually build it in terms of code, right? So you simply execute that, and it provisions the service, right? Or it recycles the service, it upgrades it, or whatever it is, right? So you don't really have to go through the painstaking approach of having to look at physical systems and try to get them procured or commissioned and so on. You can just write code and get it done. So CloudOps engineers would look at infrastructure as code, right? And it's extremely powerful. There are tools like Terraform, CloudFormation, and so on that you can use. Okay. DevOps. Now, DevOps is one of the most misunderstood terms. Okay. What people think of DevOps is almost how they think of SRE, right? I'll come into SRE. However, people think DevOps is basically the combination of developers and operations teams. Okay. You basically get a developer to do operations work and an operations engineer to do development. That's not how it works. Okay. It basically is a set of principles. There are guiding principles there. I'll go into detail on that as well. To shorten your delivery life cycles. Basically, remember that wall I told you, right? Between the developer and the administrator. It actually aims to break that wall. It does not necessarily mean that an operations engineer would do development or a developer does operations. Okay. You break that wall through automation, through collaboration, and it's more about, interworking. There's a heavy focus on team collaboration, okay? And that is the fundamental of DevOps. Now, there is an element of coding involved as well, because it involves both communities, right? The developers would focus on feature development. The operations engineers would obviously build infra as code, okay? There are certain instances where the operations engineers would also do some level of coding. However, that's mostly limited to configurations and so on. Okay. If required, they can do the development themselves, but it's not mandatory. It's just a set of guiding principles. You get an added version of this called Devsecops, okay, which introduces security into this whole thing, right? So how do you plan to have security instilled into your development life cycle or DevOps life cycle right from the very start, right? The time you start gathering your requirements, you're eliciting the requirements and so on. How can you build the security features in from there, okay? Right from the start. Similarly, from DevOps perspective, how can you build operational stability from the inception, rather than a developer building something, throwing it into operations, right, and expecting an operations person to work. Similarly, you don't expect a developer to build something and hand it over to a security expert to manage the security threats that come after. You involve them in the whole process of elaborating the requirements, designing it, and so on. Okay, so as you see, it's more of a collaborative way of working than anything else. Now, CI/CD and so on actually helps DevOps. Okay, it's not mandatory. However, it is one element that goes with the automation aspect of DevOps. Right? It helps reduce errors. It helps reduce disconnect and so on. Right? But it's not mandatory. Then comes the next element, which is AIOps, and this is quite interesting. Okay. AIOps is where you'll think yourself as an operations engineer. However, understand that during operations, any production life cycle, while it is in operation, you would have quite a significant amount of data, right? And production data, how the systems are being utilized, who's using what errors came up, right? Maybe let's just take a shopping example, right? So if you go to Amazon.com, from the data that's coming up in production, you'd be able to understand what your buying patterns are. Okay, and if you noticed an interesting thing on Amazon, it also tells you people who looked at this item also saw this, right? So there is some kind of intelligence going on in the background. Now, while that is business intelligence, learning your spending patterns, learning what others spend on, so on, right? Even your Facebook, if you look at it, it's so well curated, right? All your interests come in. Another example is like, sometimes if you have it on Facebook and if you allow it to track every single thing you do, you may be actually just talking about something, right? Maybe you want to buy something, and then without you knowing, the next time you launch Facebook, you see an ad for it, right? And you wonder, how did that happen, right? You may have had a different conversation somewhere else. However, Facebook is watching what you're doing. So understand the amount of data that comes in life is in the production operations is significant. And that is data that is usually not seen in development. Okay, so what AIOps does is we build AI and machine learning concepts on top of this big data, right? Basically, all this data is stored into HDFS or wherever that big data storage format is. And you build specialized analytics engines to come out with patterns, right? For example, can I predict that the usage of a particular service is going to increase exponentially beyond my capacity limits in December? Why December? Holiday season, right? People may want to shop more. So more people want to purchase a certain item, right? So my purchasing section, rather than just be browsing and the front page, needs to be more active, right? My disbursement needs to be proper, right? My costing and pricing and the what do you call credit management features or the billing features need to be highly available at that time. So can I use tools to minimize downtime on those, right? This is what AIOps aims to do, okay? It can actually help restore service in case something goes wrong, okay? And there are certain elements to that. There are certain applications of it as well, not all. It does not aim to completely replace a human, but simply assist an operations engineer in taking decisions, okay? And that's AIOps. SRE, this is absolutely interesting because a lot of people think SRE is the next level of DevOps. And that's furthest from the truth. It's not. SRE in principle is basically a carbon copy of DevOps. It implements DevOps, right? All the DevOps concepts, which we will go into in the next slide, will be implemented by SRE. And what an SRE is focused on, while DevOps focuses more about shortening delivery times, SRE focuses predominantly on reliability. How do we make sure that your system in life is reliable enough? Okay, that is the purpose of SRE, and it actually has many similarities like with DevOps as well. It looks at embracing risk as normal. You would eliminate toil, which is through you get rid of monotonous work. You automate as much as possible. However, one difference is that an SRE, a mature SRE implementation, requires SREs to focus on development as well. Basically, SREs are engineers and developers at heart who would code 50% of their time, while 50% of their time is spent on operations. The whole concept of SRE is to reduce the operations effort or monotony as much as you can, so that you can build new features. Okay. However, you have a focus in terms of trying to build reliable features as opposed to just simply pumping features out, right, for the sake of it. Okay. That's SRE in a nutshell. NoOps, this is like basically the state of nirvana. Even SRE talks about NoOps. Okay. DevOps talks about NoOps. AIOps talks about NoOps. All of these do talk about NoOps because that is the state of nirvana. In such a case, it does not mean that no operations effort is required. It is required to create these bots of sorts that would actually work on the operations or build the applications in such a way that manual operations are limited as much as possible. Okay, so does that mean that if you go into state of NoOps, the TechOps engineers have no job at all? Not necessarily. They are the ones who know what a production system looks like, right? They are the ones, or SRE for that matter, they are the ones who would be able to code and build these bots, right, to handle these failures or handle these particular situations, right? Or build the application in such a way that it is more resilient and requires less rework or manual effort on production. Okay, so in all cases, the underlying concept of this operations, once it has been deployed, once something has been deployed, is called TechOps. Okay, so all these are facets of TechOps. There are different ways of doing this. Okay, and neither one is better than the other. There are cases where you'd want to go SRE, and there are some cases where SRE is pointless. It's just too expensive and it's unnecessary, right? So it matters on the application really and how it's being used in life, all right? So with that in mind, let's go and focus on DevOps. Now, DevOps is based on a few key pillars, right? And we call it CALMs, basically culture, automation, lean, and measurement and sharing, right? So to implement DevOps, you first need to have a co-working culture. Basically, the boundary between the developer and the operations engineers have to be broken. They need to share a common goal. Rather than simply passing on a build to the production engineer to deploy, what you do is you bring the engineer, the operations engineer, into the delivery lifecycle upfront so that when they start looking at the requirements elicitation and so on, they can start thinking, where can this fail, right? I know how production works. I know what threats are there in production. Maybe while people are using this particular feature, what if someone does this, right? Introducing the operations engineer here at this stage will help build a reliable system, okay? They'll be able to think of a better approach and how to keep it more operatable, right, in life. And in case I need to, in case it does fail, what corrective action can take place, okay? How do I monitor all this stuff? That is something that an operations engineer would look at, right, from a delivery cycle. Again, I mentioned they are not particularly required to code, but a DevOps engineer, right, in this case, the operations engineer would focus more about how do I automate this, right, which brings you to the next line. I have a delivery pipeline, right? So I just build something, I test it and then deploy it, right? Maybe you spawn your Docker containers and so on in live and so on, you put it there. But if you look at this process, it's so monotonous, right? And things can go wrong. Each time you have manual activities in place, things can fail, okay? Why? People are not perfect. Neither are machines, but the machines actually are able to do repetitive tasks way better, okay? So the element there is automation. So what does CI/CD, CT is continuous testing, right? What does that aim to eliminate? Now that aims to eliminate the problem of it works on my machine, but it doesn't work on yours, right? There's a very famous thing that happens in software development. Someone develops a software, an application, sends it out to the testing team. The testing team tests it and says that, okay, hey, I have these bugs, okay? But the developer says, look, it works on my machine, right? And the tester says, no, it doesn't. It's not working on mine. Fine. They work together and fix it and then deploy it onto production. The operations person says, what have you done, right? On production, it's just failing. And then the DevOps people, the people involved in the development area, deliver development and testing, they simply come and say that it works on my test environment, it works on my dev environment. Why isn't it working on ops, right? Why isn't it working in production? And then there's a back and forth, okay? So to eliminate this whole process, there's something called CI, CT, and CD, right? So where you actually, and this is where IAC and infrastructure as code is also very useful, right? Where you can simply automate the spawning up and creation of the configuration, the creation of the infrastructure required, right? To build a particular package and deploy it onto a test environment to run the relevant test cases, right, without any human intervention, right? To replicate the same package onto production exactly the way it was intended, okay? Rather than the production environment being something else and the test environment being something else, the dev environment being something else, right? So this is what the pipeline aims to achieve. It's not just about automating the deployment from development to production, okay? It's also this. Third element is lean. So this is where in DevOps, one of the fundamental things is you need to look at how well you're performing and things that you're running as wasteful items. And what I mean by waste is basically something that is non-value adding, something that the customer is not willing to pay for, right? And when you do the math, and if you check out how much of tasks the customer is not willing to pay for, I mean, they're not willing to pay for bugs, they're not willing to pay for defect fixes and so on, right? But they are willing to pay for new product, right? New features. So lean aims to eliminate these unnecessary things, the waste. So if you have defects, one part of it is to make sure that you have less defects next time, right? How do you incorporate processes to ensure you limit your defect leakage, okay? If you have workarounds, manual workarounds, how do you aim to, either through automation or elimination or whatever it is, get rid of that manual effort that's required? That is called being lean, because by having a lean team, you're able to think as an agile process, right? You're able to work as an agile team. You fail fast, you learn out of it, you automate or simplify or eliminate that particular task completely, and then you move on as a lean team, right? And then you move on to the next, so okay. So once you have that, the other fundamental element is measurement. You can't really do anything without measurement, right? So you do not know where you are going, where you're headed, how good things are, if you do not measure, okay? So if you and by measurement, I mean things like, all the way from the development, your requirements index, clarity index, all the way into your defect severity, the defect leakage, amount of issues in production, turnaround time for issues, cycle time, and so on. All that stuff has to be measured, right? And more than this, it's also the measurement of production operations, right? Your throughput of the system, all of this stuff does come into play. So you need to measure every single thing that goes on, right? Baseline and quantify performance there. Finally, sharing of tasks. And this goes hand in hand with culture. It goes back to the first pillar as well, where in certain cases, the developers will share operational workloads. So the developers have this form of, understanding, mutual understanding between the two, between the operations team as well, where the developers say that, hey, look, okay, I put you in trouble last time. Let me do some of your operations work. I brought in this workaround. Let me not burden you. I'll do some of this, right? And I'll help you script it. The operations person says that, look, okay, I know you're busy with the development. So, you're doing some great work with development. You're reducing the amount of defects. Let me also start, building some features with you. So that kind of sharing, right? And the knowledge sharing, the interworking, that is the culture that DevOps, instills, right, in the way of in software development. So just note down the terminology. It's just called CALMS, right? Simple abbreviation for it. And if you do this, this is a proper DevOps implementation, okay? So this is important and paramount to understanding the very next concept, which is SRE, all right? So SRE is basically a prescription. It actually prescribes, while DevOps is very loosely termed, right? It just, if you noticed, it's very loosely termed. It doesn't tell you exactly how to do things, what to do, and so on. SRE prescribes exactly what to do from an operational standpoint, okay? But understand it also applies to some development part because it's a whole culture, okay? The whole concept of DevOps and SRE and whatever it is that, the teams work together. You don't think in the terms of an operations team and a development team, a product engineering team, etc. You don't think of them separately. They're all one big unit, okay? They're one product team. So SRE is the fundamental thing, is what they do is they embrace risk, right? So remember the second slide that I showed you, things can go wrong, right? We don't know when things can go wrong, right? Murphy's Law, okay? So you embrace risk, understand that things will go wrong, and you build systems, right? Or you build a ring fence around it to prevent any failure, right? As much as possible, or for it to react in terms of in case of a failure. Okay, how do you recover? How do you restore the reliability of a service, right? How do you restore a service when it has failed? The next one is your measurement, which is service level objectives, okay? So again, this goes to the pillar of measurement with DevOps. We have things called service level objectives, and these are not just simply ticket response time and so on. Those are there, great, right? However, what I'm talking is about monitoring the actual application in life, right? So you deploy something in life, you may have the throughput of a system, you may have the error rate and the hit rate and so on. All these are different service levels. They're called SLIs, or service level indicators. Now, from a service level indicator, you build an objective saying that the throughput has to be more than 80%. That is known as a service level objective. Availability, right? 99.99% of the time, the system has, this particular service has to be available and usable by X number of people, right? At least an X percentage of people in the country. That is an SLO, it's an objective. The moment you put in a target on something that's measured, or a combination of measures, that is a service level objective, okay? Your system has to be able to achieve those objectives. Okay? Third one is eliminating toil. So SREs hate manual work, right? They really must detest manual work. So the automation pillar in DevOps, okay, this is exactly that. Anything that involves manual work, like restoring service, or like, running a workaround, or even manual deployment, all that is toil, because an operations engineer would rather spend that time building a more stable system than, being engaged in toil, okay? Monitoring. This goes down to SLOs as well. So now you have distributed systems, you have many microservices and so on. The way things get monitored is very different, right? The system has to be built in such a way that facilitates monitoring, okay? And how does the system get built that way? By having an SRE come in and work on the code and saying, okay, look, in production, I need to build my system this way to output these metrics so that I can measure my SLOs and so on, right? I can use various tools to what you call actively monitor. However, the system also should be capable of doing that, right? Of outputting those metrics. So that's the concept of monitoring distributed systems. There's a newer one, which is called release engineering. This came up somewhere 2016, if I'm not mistaken. And this is the process of, it's actually a dedicated role, which focuses purely on managing the release from delivery from development all the way into production. There are various aspects to this, like what type of quality gates we need to put in, what checks and balances are required, the SLOs, how do I meet them during the release, right? How do I make sure that there's minimal toil when it goes live? What type of process should I implement? How much automation should be there? All that stuff is the purpose of, is the job role of a release engineer, okay? And that's a dedicated job from compared to an SRE. It's a dedicated discipline. Finally, keep things simple, right? But not too simple, right? So this is fairly straightforward, right? There's a small acronym called KISS, right? Keep it simple, stupid. Okay. So what happens is, if you make things more complex, remember the very first slide, you keep on making the production system more and more complex. The more complex it gets, the more difficult it becomes to maintain, right? And one of the primary things of, one of the pillars rather of architecture, good architecture, is maintainability, right? Can it be maintained? Now, the more complex it gets, it becomes a nightmare to maintain. You get a huge monolith, or even worse, you have microservices, you have too many of them, right? And you build each of them very complicated. What happens? It's a complicated mess. It's a distributed mess now, right? So you'd rather keep things extremely simple, especially even if you take service level objectives. There's a mandate that your service level objective should be simple and clear. It shouldn't be something super complex, right? It should be very easy to understand the math behind a service level objective, okay? So that's the concept of SRE, and it goes into a lot of prescription. There's actually a whole book. If you want to learn about SRE, I'll just show it to you as well. But yeah, in a nutshell, this is what SRE does. So to prove a point, I actually ran a LinkedIn poll, right? Probably last week, if I'm not mistaken, or 2 weeks ago, just to understand what the public thinks about SRE in comparison with Devops. So if you look at this, I didn't give none of the above, and actually I gave all the wrong answers here, right? All of them are incorrect, right? None of them is correct. However, you see there is a spread, right? It was so disparate, the answers that came in. About 45% of the people thought it was the next level of DevOps. But what is the next level of DevOps? It means DevOps isn't doing something good, so let's have the evolution of it, right? That's not it, okay? And then some people did say that it has nothing in relation to DevOps, whereas it is exactly an implementation of DevOps, right? Although it is not a way of running DevOps, right? It's not a different way to run DevOps, okay? It's a part of DevOps of sorts, right? Some people said it has just similarities with DevOps. Not really, because if you say if it has similarities to DevOps, that means there are certain parts of DevOps that are not implemented with it as well. That means it should have differences from DevOps. It does not, right? It is 100% the same as DevOps, okay? Just that it has certain other additions to focus on reliability. That's all it is. So basically, understand this concept. Google came up with this great terminology. Class SRE implements DevOps. And it's just not a normal class, it's a concrete class, which means it implements all DevOps concepts fully, okay? You have other, what you call frameworks as well in service operations or TechOps. You have something called ITIL4, right? Or IT Infrastructure Library. It's no longer just called that abbreviation. It's just called ITIL4. ITIL for the fourth industrial revolution. That's what it's called. So you can implement elements from that, but it has to implement everything of DevOps. Okay, that is called proper SRE. So if you want, there is actually the poll is available as well, and I provided a link to the blog post as well that goes into a lot more detail about it. Take a read, because you'll understand what the main differences are, right, and how not to get confused. I eventually also show you what really SRE is in comparison to DevOps, apart from the things that are incorrect. Okay. So here's the mission, right, statement, and this is basically how you'd actually run mission critical applications, right? And you know this concept called the Maslow's pyramid of needs, right, or the priority, right? Of basically the one at the bottom is your fundamental requirement. Okay, the one at the top is almost like a value add or something that's a nice to have, right? So understanding the pyramid of needs. Okay, so you start, one of the most important things is monitoring and observability. So like I said, if you can't monitor something, you can't gauge what it is, you can't understand its baseline performance, right? You basically are blind to what's going on. So the first part is, your first priority of SRE is to monitor the system, right? Get your metrics out first. Second thing, once you have your metrics, you need to then focus on incident response. What if something goes wrong? Okay, in case there's a failure, do you know how to fix it? Right? Are you actually alerting based on the stuff that you're monitoring now? Okay, that is the incident response. Once you fix something, SREs really hate fixing the issues over and over again, right? A repetitive issue. They don't like repeating the solution to a particular failure. So what do? They look at root cause analysis. So root cause analysis, or something called blameless postmortem, is what we do. By root cause analysis, some people just think of root cause analysis as, let's blame this person, right? Or, okay, what's the root cause of this? This person did something, or it was a human error here, right? Even if you take certain things like, running a few commands and deleting an entire storage system, you'd actually pin that as a root cause. Whereas the root cause of it is, the actual root cause of it is that there's no backup. Okay, the root cause of that failure, that may be one root cause, the actual system, the actual command being executed. But then there's a second root cause, that the backup was not there. The next root cause is the system actually allowed the command to run on production, okay, without maybe a check and balance of it. Okay, so this is where you look at, diverting the, not almost, you don't blame the person, because people can fail, right? People can make bad mistakes or bad decisions. However, the systems need to be built in such a way that are reliable, right? That is SRE. Then comes testing and release process. So now here is where testing will help to prevent failure injection. Remember, I mentioned every change you deploy can cause an issue, right? So you enhance your test mechanisms. Once you've built all of this stuff, you enhance your test mechanisms to prevent future failures. Okay, and testing does help this. Finally, once you're properly tested, you look at capacity. Now I have a good testing process. Is my infrastructure, or is my deployment able to scale, right? Is my team able to scale? Okay, you need to look at capacity from all areas, right? Avoid saturation. Basically your infrastructure should not be saturated too quickly. Your disk utilization should not creep up so much. Do you have spare capacity? Is your application scalable, right? That kind of capacity planning based on forecasts is needed. Finally, once you have all this, that's when an SRE can focus on feature development. That is building new features and so on. Remember the 50% of the time that the SRE has to spend? That is where this comes in, after all this is set up. And finally, once you do all this, you have a product worth selling, okay? So this is basically the pyramid of requirements and necessities for an SRE, okay? Just want to take the example of the bottommost part of it, the bare bones necessity. So when you think of monitoring, one of the things that come to your mind is, what should I monitor? How should I monitor, right? When should I monitor? How can I display it? Should I really monitor this? Okay, good thoughts. And then some people think that, okay, let me just install this tool. It can monitor everything, right? But not necessarily the case. A tool isn't going to solve your problem here, okay? You can build fancy dashboards, right? You can build AI into it, AI ops, all this little stuff. But if you do not know what to monitor, then you have a problem, okay? So let's look at monitoring. There are certain components to building a monitoring system. One is, how do you collect the data? Do you pull the data, that is extract or query the system for metrics, or do you get the system to push metrics down to your monitoring system? Data storage. Once you got it, how do you store it? What format do you use? Okay. Do you use JSON? Where do you store it? Do you store it in a time series format? Right. All that is something to consider. Visualization. Now that you stored it, how do I see it? Right. How do I see it in my dashboard? Do I use gauges? Do I use whatever? Right. How can I see this? Are the metrics that I stored visible? Right. Can it be visualized anywhere? Once you build the visualization, what analytics can I gauge out of it, right? Is it worth even monitoring if I can't understand what this is, right? If there's something so complex in there and it does not make sense to me or anyone, or it doesn't have any value, is it really required, right? And finally, the alerting part of things. So if I monitor something, can I alert based on this? Does it, qualify for an alert? Should I wake up my operations engineer in the middle of the night for a failure here? Prime example, disk utilization hits maybe 80%, right? And you wake up an engineer on call. Is that good? Not really. Each time you disturb an operations engineer, understand it's a bad vicious cycle, right? You interrupt the person, and then that person spends some time. It's sleep lost. The next day morning, the person wakes up. They are very groggy. And then they go to work. They start trying to figure out, okay, what was the root cause, all that stuff. Only to realize, okay, 80%, great, your alert tripped at 80%, but you have maybe about 100 GB remaining, 100 GB extra. That 20% that was remaining was about another 100 GB. Was that a real cause for alarm? Not really. It was just that your system is, doing what it's supposed to do. You paid for X amount of storage, right? Your what you call system is using it, right? But being alerted at maybe 99.5% or 99%, and depending on the growth rate of the utilization. Now, if you have a combination of those two, that is something worth alarming for. Okay, something that has that will cause an imminent failure of a service level objective. That's something worth alerting. All right. Data types. There are different types of data, and this is where you look at, we call a common concept called MELT, right? It's metrics, events, logs, and tracing. So you can have metrics in terms of counters or gauges. Counters are things that keep incrementing. Gauges are spot changes, either, maybe 0 to 100% or whatever the rate is, right? Events are things that the application can, trip. Say, for example, it has an error or it has executed this particular function. That is an event, all right? Then you have logs. Logs are basically anything that can be stored in a flat file or database or an audit log, a trail of sorts, right? And finally, you have things called tracing. Tracing is basically, especially in microservices, a transaction comes through, a message comes through. Can you trace it through all the other service interactions and its response times, etc., all the way through, right? End-to-end tracing. Can you, by looking at a particular message ID or a transaction ID, can you just build a huge map on how it has performed right through, rather than just looking at the overall round trip time? Finally, we have things called 4 golden signals. Again, these are prescribed as SRE by Google, which is latency. Latency is, if you have, say, responses. Let's take REST web service or HTTP responses. You'd have, say, you're looking at HTTP 200s, okay, the success response. You look at the latency, how long does it take to respond? However, you'd also want to look at the latency of an error, right? So if you say HTTP 500, it is an error response, okay? You are getting the response. Now, understand one thing, there's nothing worse than a slow error. A fast error is better than a slow error. If your system, you just load a page and it takes maybe 2 minutes, right, to load, and then eventually you get an error back. A lot of frustration, isn't it? Compared to actually getting the error much quicker. If it's much quicker, you try a reload. But imagine you wait for 2 minutes, you probably close it, you don't want to try it again, right? So latency is one important thing. Traffic. Traffic is the rate at which, say, something is being used, okay, like hit rate or error rate even. That's called traffic, right? Errors is basically any event. It goes down to events. If there's any, say, exception or a major error or failure or something, that's logged as an error. And saturation is how much of a system or capacity is used, right? Again, going into CPU or memory utilization, right? Or even JVM heap utilization, if it is like say 90 or 99%, that is saturation. How saturated is your system? The more saturated it is, the more difficult it is to work with. And monitoring has two different concepts like black box monitoring and white box monitoring. So all what we spoke about now is white box monitoring. That is looking at the nitty-gritties under the hood of the system itself. You get this whole other concept called black box monitoring, which is looking at it from an outside external perspective. How does the user see it? Okay. You get different concepts like real user monitoring system, synthetic monitoring, and so on. So how does a user see all these things? All right. So this is basically monitoring in a nutshell. It's just on one slide, but there's a whole load more that goes into detail. Okay. So a typical day in the life of a SRE or any TechOps engineer, you'd have issues. You can either detect it through monitoring alerts. You can implement chatbots. You have self-diagnostics. You have monitoring dashboards. You have concepts like the help desk and so on. They do the triaging. You would have things like where you acknowledge things within less than 30 minutes, 15 minutes, whatever it is. Then you have the SRE team, which is responsible for the service restoration, the postmortems, etc. You'd have your DevOps engineers who would actually work on doing the features. However, understand SREs also do coding and development, so they push it through the CI/CD pipeline, especially any remedial fixes, right? They can be automated as much as possible. So you look at self-healing systems and so on. But eventually, what needs to understand, need to understand is every service needs to be monitored and reported. You need to have a view of service levels, what the knowledge repositories, basically, if something does happen second time, can you follow a set of guidance principles to actually remediate it again, or can you script the solution, or completely fix it, right? So this is basically a day in the life from an incident perspective. Change perspective is quite different, right? I just wanted to show you the flow. So great, now you understood about TechOps, right? In a nutshell about TechOps. However, one thing to understand is it really for you? Okay. You may be aligned towards development, you may be aligned towards QA, quality assurance, and so on. And but if you want to get into TechOps, one of the fundamental things is you need to understand, are you willing to learn more than the software lifecycle, right? More than just agile, more than low code, no code, and all that stuff. It is technical indeed, right? There's a whole load more, and it's actually an engineering discipline. But are you interested in learning the other side of things? Okay. Are you passionate about challenges? Because every day in the operations lifecycle, the life of an operations engineer is quite different. You will get issues that you have never heard of or can replicate in the development lifecycle. You may test it as much as you can, but in production, when things fail, they fail in very interesting ways. Okay. Do you like that challenge, right? It does not mean that you should always look for failure at any given time. It's great if you can react to it, but that adrenaline rush that you get out of it is something amazing, right? Third one, can you actually be a good detective? Can you look at your blameless postmortems? Can you look at root cause analysis without bias? Okay. Are you able to look at things rather than looking at just symptoms? So as an example, if you look at data loss, right, or if you look at maybe any system of unavailability, whatever it is, can you look beyond someone saying that, okay, this person ran this particular command? Okay, can you go beyond that to say that, okay, but why, right? Why did this fail further, right? Can you go beyond that? That is basically what you need in this case. And finally, and most important, you need to be an engineer at heart, right? You need to be able to do some level of software development, unless you're doing sysadmin, but even that you would need to look at scripting and so on. So you have to do some level of coding. You can't escape that, okay? It gets more mature when you go into SRE. So all of this is required to do TechOps, okay? It's not just learning a programming language and design concepts and getting things done. It's a lot more than that, all right? So if this is for you, then probably you may want to give TechOps a go. So finally, we've launched a a community, right? A TechOps community on LinkedIn, and I encourage you to visit it. You can scan the QR code, visit the LinkedIn community, add on to it. It is something that will be public, and we encourage everyone in the Sri Lankan community to start engaging. And you can publish your own content. We can record your webinars. We can have multiple conversations about it, collaborate, do a knowledge share as needed. You can have tech talks, right? Similar to the one here, right? And we will publish these as well over there. However, just feel free to join, and this is open to the public for you all to join in. The whole idea is so that we can collaborate and work together to build TechOps as a community in Sri Lanka, something that will completely, because this is an untapped potential. You have development, you have QA and so on, but TechOps is something, almost unseen. Even though there's a lot of work, there are a lot of capability in it. So let's build this capability in the country as well, right? So feel free to join. So with that, thank you very much for listening, and I'll hand it over back to Sampath.
Right, let me come on video. Hope you can see me. All right, okay. So thanks, Misnad. That was very insightful. There are some good questions that has come up, and I'll take at least 3 or 4 questions where you could enlighten us on certain areas.
Sure.
Number one is that most of the audience today are students who's joining. Of course, there are ones who are in the Devops field who are joining out of the interest. You did justice for them. Thank you so much for that. But most of them are actually from university. So they do, you don't have a Devops, a degree. They would do something like a software engineering degree or a computer science degree or some interdisciplinary degree, right? So one question they have is, if you are a graduate, undergraduate, now if you wanted to now itself try to align to what you just mentioned, what should they do?
Right. See, like I mentioned, it's not just about understanding technology, right? That's a fundamental. You need to understand how engineering works as a principle, right? And this is where, Sampath, what happens is, when you learn about coding and development, you end up going into the development field, right? It's natural, right? The natural progression is that. However, try to lean towards you get various other courses that come out, right? Like on Udemy, Coursera, and so on. I encourage you to actually go through some of those to understand, cloud. Let's look at cloud, right? Cloud administration. How do you administer that? But one thing to understand is you can know about, the infrastructure behind things, how things are done using automation and so on. You can even, create your own environment. Try to replicate your own environment. Don't try to develop something new. Take some code that's already developed somewhere. You get different on GitHub. You get various already pre-built systems, right? Take that and try to deploy it, right? And then you get simulators to actually, execute how real life load looks like, right? And then just see, in case something fails, how do you go and fix it? Okay. From that, we should not try to get ingrained into all the processes behind this whole thing. Okay, but that's what really breaks the interest of things. When you go into too much process, obviously, you want to do things more agile. So try to understand how you would fix things. Once you've done that, go through some of the courses online, right? Read some of the books, and actually, this is a really good book, right? It's basically how, I'm not sure whether you can see it because of the blur filter, but it's about site reliability engineering, right, from Google. Really good book that you can look at. However, one thing to note, you won't get, unlike development, you won't get operations experience unless you do it yourself hands-on, right? So unless you get into the industry with that note, you will not get the hands-on experience. And there's nothing like teaching you that, okay? Sorry, Sampath, you're on mute if I'm not, I think.
I'll unmute. Yeah, someone is asking, is it possible for you to put on chat the name of the book? So probably should do that a little later. Sure. And also another question is, if I get you up to speed, I know there are people in this audience who are like really knows about this subject, but I need to do justice for some majority who are kind of not very much specialized in this area. So let me take 30 seconds and get you quickly up to speed, right? So you know that your client has a problem. They come and ask from a consultant, IT consulting company, can you give a solution? Then you decide on a solution, and then the software developers or the engineers develop the system. And then you all know those code will be in some code repository, and that code repository, we will have to push them into a, early it will be on a testing environment. Then later on, you will have to push it into a production environment. Those days, those production environments were in-house on-prem, but now most of those production environments are on cloud. And also those days we had this, very strict testing, and then basically putting these things and pushing these things to production environments. But DevOps is where, as Misnad mentioned, continuous integration, continuous, CI development, where those build processes to pushing them to production, and that whole thing happens end to end, right? That's and also, as he very rightly mentioned, he went up to the 30,000 degree level, feet level view of what's really changing out there, like the infrastructure. Those days you were working with the infrastructure. Now the new infrastructure engineers are actually doing those things using the code, right? So this is what we are talking about right now. Now there is an interesting question, Misnad, again someone is asking. So okay, what if I am already a software engineer? Okay, maybe we all know, I'll come into that later on also regarding the opportunities. Maybe at the initial stage of the career, they might be joining as just a software developer, engineer kind of a position, or a QA engineer. And we do not, as technologists, recommend for them to pick and choose at the initial stages when you're doing internships and all, because the best thing is for you to get into an organization and get some sort of good quality internship going. But after some time, they would decide to move into this area, right? Maybe you were in QA, maybe you were in development. Now you wanted to move into DevOps, right? Yeah. So you just mentioned as an undergrad what you need to do: go study Udemy's and Coursera's and things like that. But if somebody wants to move, or is it like a separate track? Or is it like while you are a developer, also you need to know the DevOps? So how does that whole, I'm sure the boundaries are also getting blurred these days, right? What's your take on that?
It is, Sampath. So the thing is this, right? First, let me just tell you, when I started my career, I was a developer, right? So I started my career as a software engineer doing code, right? And then I decided, look, while developing is interesting, let me also, just try to get my hands dirty in this, right? And very interestingly, I kind of liked it, right? Basically, I love the adrenaline. Okay,
right.
You actually get you get hooked onto that, right? So the way to shift there is when you work in DevOps. Okay,
a normal day becomes a boring day. You mean to say? A normal day without a problem becomes a you get high by seeing those.
Correct. Because
I get you.
Right? Different. Yeah. It's completely different, right? And see, if you look at the concept of DevOps, it advocates that a developer should do some element of operations as well. Okay, so it's not about developers getting into DevOps. It's about unless it's in the legacy way of working, right, where you're shifting entirely from developer sysadmin into DevOps, right? But even a developer these days should be DevOps, right? Basically, you should be able to at least understand if, say, the service goes down, what can an operations engineer do, right? So getting into that it doesn't require a full shift, right? It can be staggered these days. It doesn't require you to completely become a TechOps or a sysadmin or something like that. You can take it in. You can just share the load with the operations folks, right? That would actually help you.
Okay, great stuff. So in the interest of time, I'm going to ask you last two questions. So they both are all in the common theme. They're asking what are the opportunities. We see quite a lot of advertisements, for especially we need full stack developers, we need automation engineers, like that. We see so much of job applications, job vacancies, adverts on LinkedIn and various places. So one question that they have is, what type of opportunities are out there? Are there a lot of opportunities? And also what the future is going to be. Do you think that there is a huge demand, particularly the local context? Yeah.
So if you look at things, right, so we have a lot of startups, right? We have a lot of software companies coming in building software, right? Like I said, it's easy to build something. You can learn that, build it. It's great, right? However, you also have to take care of it once it's gone live, right? So the more you develop, the more you need to take care and nurse, okay? So it's actually something that's going to keep on growing, right? And unless it is tapped, someone else is going to do it. Right.
Okay.
So it's in our interest really to go down there and basically look after what we have built. Right. So just think, right? You build something, you spend some time, you build a car, you'd want to see it maintained as well, right? You just wouldn't want to, just hand it over. So that's the whole idea.
That's right. So is it like, sorry, this is just something, I don't know if it's the right way of looking at it. Now, if you say, now sometimes you have, IT-enabled services or managed services organizations in Sri Lanka. I mean, we also, Virtusa also represents such, organization, right? We are of course, an end-to-end digital transformation organization, yet there is predominantly it's outsourced and managed services. So if you look at like the opportunities from a software engineer to a DevOps engineer, like it is like 10 to 1 or what, can you look at like a percentage or a ratio basis? Yeah.
Okay. So the rule of thumb is basically if you have say 100% team, right? Usually about 60 to 70% would be your developer team size, right? And the balance 30 to 40% would be operations. So you'd look at almost 60-40 kind of blend, and it's obviously blurring because now they do have the common goals as well, right? So
absolutely. Okay, my last question. I'm sure you might not be able to probably directly give numbers, but of course the audience is interested about knowing how rewarding is this career, as a career. What is the starting pay? Is it like exponentially growing or yeah? So anything on that aspect you can share, Misnad, because you are a senior person who's been in this for a long period. I'm sure you have much more visibility where you can share some insights with the audience.
Sure. See, while it's good again about development, right? And I actually do love development too. Okay. It's important that you understand what really interests you. Okay. And what do you consider rewarding? Okay. Do you consider rewarding something like, learning something brand new, right? Or do you consider, like I said, the challenges, right? Do you consider that something rewarding? If you're looking at what you call things like compensation and so on, they are on par, right? There's no, nothing against that. I mean, you do work on shifts, right? You get compensated based on that as well, right? And especially in the local context. And it's your objective really is to, the biggest reward, what I get out of this whole thing is I can develop something and then I can see it go live, okay? Basically, I push the baby live, right? And that's something that you can't replace that rather than handing it over to someone else, right? So that's the biggest reward you can get. But again, in a nutshell, Sampath, it's about understanding what reward you're looking for.
Absolutely. And there's some people who are very interested about immediately start an internship. Is asking, hey, does Misnad has already internships available to give at Virtusa, or maybe are we like recruiting people? So probably you can share a few thoughts on that. And also my recommendation for all of you is, now Misnad is one of those, just like Prashant, Misnad, and the rest of the others, they're all very, very active on social media. He has his own blog, he has his own LinkedIn profile, and as well as he just created recently a community for I think a couple of days back he basically created a page for the entire Sri Lankan community to get together, because we are not looking at one company. I mean, that days are gone. You look at as an industry, you look at as a career, you look at as community, because the same people who come to a company will exit the company and later on become again. So it's the same industry, same company, same community. You will be basically rotating. So we have to look at this as a talent pool where we have to look bigger than smaller companies. We have to look as a geo, or we have to look at Sri Lanka, where we will have to benchmark ourselves with the regional geos like the other countries, right? So that's where we wanted really want to kind of build these capabilities. If we wanted to do it, we'd have taken 20-30 people from a university and do these TechOps or these things. It's not our objective. It's about building the capacity in Sri Lanka. As a company who's the #1 IT firm in Sri Lanka, we wanted to actually do it as our responsibility to the country as well, because building capacity becomes part of our responsibility. So, Misnad, do you already have certain opportunities we can give to our, the ones who are really interested? And if so, how could they contact you?
Yeah. So we actually have been doing this for quite a while now, and see, like I said, it's like until today, right? We've always been focusing on development, right? While we even did this, in the background. So if you want to get into internship, and I believe, like I said, hands-on experience is the best way to learn, right? While you learn about development and so on in your university, this is the best way to learn, right? Through an internship. So you can actually, we have published several requirements for interns as well. You can respond to them. You can join us, right? And we actually have different teams that are working with different clients, right? So you get directly involved in them. You start working with them directly. You don't become something like where all the monotonous work gets dumped in, right? So you will actually get into that. But one thing to understand is always be clear what the internship is about, because not every internship is the same. Okay, so you would have some internships as SRE, some internships as you get cybersecurity as well. I think someone had asked about cybersecurity opportunities as well. You get that as well, right? And then you get others in terms of doing command center kind of work, right? Basically coordinating issues and so on. You get multiple of these. So be very specific and ask about what the internship is and what their role and responsibility is going to be. That's my advice when you get into internships, but that is the right way forward, right? You can always contact us through our HR teams who are available. You can visit our homepage. You can even send us a message on the what you call community as well. You can simply post it up if you want to, right? And it's not just Virtusa, right? I think anywhere, right? You can, because the community is open, okay? So you can actually just post whatever you require, and obviously we can work out some internship for you.
Definitely. We are looking forward to anyway, whenever we have your opportunities, and also please do follow, as you said, these pages, as well as our campus teams are very closely working with the universities. I'm sure there are a lot of universities joining today. All those universities, we have a representation, and we have a partnership. If your university does not have a partnership with our company, please do let whoever who's doing the career development and these internships to get in touch with us. And we may not be able to provide thousands at once, but definitely we should be able to provide you a sizable number of internships in this area. But there are as I always mention, we continue to be the single largest recruiter annually, right? About 400 to 500 interns and fresh engineers are being recruited to Virtusa, as well as we become also a supply for the industry as well, because we get to see a lot of people get this training and move out and for better opportunities outside as well as abroad and on site as well. But it's all part and parcel. We all want to ensure that all of you all have a great career. Right. I know Misnad is very, very busy. This is the time his client started working, because he provides services for a European client. Yeah. And I can see he's already glancing at his, the tickets and maybe emails, and then his dashboard started, giving those indications. So thank you, Misnad, taking time off to educate our the interest parties of this. And we wish to have more of such sessions on various different topics. And thanks again on behalf of everyone. So goodbye and have a great weekend. Stay safe. drink kottamalli. All right. See you guys. All the best. Bye.